Hello everyone, welcome to this video on correlation and regression. In this video, we are going to explore some fundamental concepts of correlation and regression. First, we are going to begin the chapter with a scattered plot. When we say scattered plot, it's a graph between the independent variable x and the dependent variable y. So we'll have the independent variable along the x-axis and dependent variable along the y-axis, and we draw the graph. We just plot the points, we just plot the ordered pair, and we look at the pattern. A scattered plot shows the direction of relationship between the variables. That is, when you move from left to right along the x-axis, we look at the pattern whether it is going up or it is going down. If it is going up, we say that there is a positive relation. If it is going down, we say that there is a negative relation between the independent and dependent variable. But if you don't see the trend, there is no relationship. So remember, the scattered plot demonstrates the overall pattern and any deviation from the pattern. So if you see any point far away from the cluster of the points, then you can say that there is a deviation. If there is one point somewhere up there, or a point somewhere down here, then we say that there is a deviation from the pattern, and such point which lies far from the regular pattern, that is called an outlier. That is an outlier. So the scattered plot will give you the direction of the relationship between two variables, independent variable and dependent variable. Let's take an example and plot these points to find the scatter plot. So create a scatter plot for the following pair of data using calculator. Okay, we are going to use calculator and create the scatter plot. So what we are going to do is we are going to enter this data between the number of absence and the final grade. Okay, so if the number of absence increases, what happened to the final grade? We want to look at that using the scatter plot. So what we have to do is in our TI-84 calculator, we go to, okay, let me show you here. We go to stat and then number 1, hit enter, and then in list 1, we enter the x values, and in list 2, we enter the y value, number of absence in list 1 and grade in list 2. After you enter the data in list 1 and list 2, you go to second and then hit this y equal to. Then it will bring this new window where it says stat plot. So press number 1 or select number 1. Then make sure this stat plot is turned on. Then here you select the first one, which is the scattered plot. There are other plots here, but we want scattered plot. We have already entered the x value in list 1, that is the number of absences, and y value in list 2, which is your grade. Now here you can select what type of mark you want to put for each point. You can put a box, you can put a plus sign. I'm just going to select that box. And then you can also change the color here. You want a blue color or a red color or whatever you want. Then after all this is selected, hit graph and you'll see the scatter plot there. If you don't see this plot on your calculator, what you should do is you should press zoom and then number 9, and you'll definitely see the scattered plot. Now you can also trace this point. If you hit trace, then you can see that's your first point. Number of absences 6. Your final grade is 82%. Move this. Number of absences 2. Final grade 86%. Number of absences 15. You're absent for so many days. No chance of passing the class. Your final grade is 43%. You're absent for 9 days. Your grade is 74% or a C. You're absent for 12 and your grade is 58%. So this graph shows that if the number of absences are more, then the final grade is low. So this is the scatter plot that we have created using calculator. So this is the graph or the scatter plot generated using the calculator. Now we are going to look at another example where we create this scatter plot using Microsoft Excel. So here is the data. What we have to do is, in order to create the scatter plot using Microsoft Excel, we have the information here, and it is about the car rental companies. We have number of car rented in thousands and revenue collected in billions of dollars here. First, we have to enter this data in Microsoft Excel sheet like that. Then once you select this, you have to go to Insert, then go to Charts here with the dot, and you can select this scatter plot. So scatter plot is right there. Now you can change the name of this one, you can change the title, and you can also rename the X and Y axis, and your scatter plot is ready. So the title of this scatter plot, car rental companies. Along the x-axis we have number of cars rented, and along the y-axis we have revenue in billions of dollars. And when you look at this one, you can see that as you move from left to right, as the number of cars rented increases, the revenue also increases. So as you go from left to right, there is a positive trend. Sometimes you can also add the trend line. If you add or if you click this plus sign and select this, okay, then you'll see the trend line. You'll see the trend line. So when you go from left to right, there's a straight line with a positive slope. Meaning of that is, as the number of car rented increases, the revenue also increases. So this is how we can create the scattered plot using Microsoft Excel. So that is the second example. In the first example, we created the scattered plot using TI-84 calculator, and in the second example, we created the scattered plot using Microsoft Excel. Okay. Now we are going to go a little bit into the detail of this scattered plot. After we have this scattered plot, after we see the relationship, we have seen that the scattered plot will give you the relationship, the direction of the relationship. Now we are going to calculate the correlation. Correlation is the relationship between two variables. That is your independent variable, which is also called explanatory variable, or dependent variable, or response variable. A scatter plot will give you the direction of the relationship between x and y variable. But the correlation, in correlation we calculate R, which is called the correlation coefficient. It measures the strength and direction of linear relationship between two variables. When I say strength, whether they are strongly positive, strongly negative, weak positive, weak negative, or there is no relation. So that can be measured using the correlation coefficient. And this is the formula to calculate the correlation coefficient. R equal to n times sum of x times y minus sum of x times sum of y divided by, in the first square root, you have n times sum of x squared minus sum of x quantity squared times the second square root of n times sum of y squared minus sum of y quantity squared. So in our course, we must know how to find this correlation coefficient R using calculator and without using calculator. We are going to learn that in the example later on. But first, we are going to talk a little bit more about this correlation coefficient R. The value of R ranges from -1 up to +1. It cannot be more than +1 or less than -1. So the correlation coefficient lies between 0 and 1. The absolute value lies between 0 and 1. If R equal to -1, if R equal to -1, there is a perfect negative correlation between dependent and independent variable. That is the meaning of that. If r equal to 0, there is no correlation between the dependent and independent variable. And if r is positive 1, there is a perfect correlation or perfect positive correlation between independent and dependent variable. Now let's take an example here. So here in this example, they have given this scattered plot, and for each of these scattered plot, you are asked to guess the value of r and interpret. We are not actually calculating it, we are just guessing it. We are just writing a random value that matches with the scattered plot. For example, in the first one, the points are lined pretty perfectly, but not very good. They are not on a straight line, but they are around a straight line. So there's a positive correlation. I can say r equal to something like 0.65. Okay, so meaning of that is there's a weak positive correlation between x and y. So the interpretation will be there is weak positive correlation between x and y. That is independent variable and dependent variable. If you look at the second one here, you can see there is a negative relation when you go from left to right, and the points are more closer than this one. So maybe I can say here r is negative but pretty close to each other. So I can say r equal to maybe negative 0.85. So meaning of that is there is a strong negative correlation. So there is a strong negative correlation between x and y. So that is the interpretation. Third one, you can see when you go from left to right, these points are in increasing order and they lie perfectly on a straight line. So you can say that the correlation coefficient r equal to 1. So we say there is a perfect positive correlation. Perfect positive correlation. So here in this example, we look at this scattered plot. We guess the value of r. We have not calculated. This is only the guessed value. May or may not be equal to these values. And then we interpret it. Here r is more than 0.5, close towards positive 1. So we say there is a positive correlation, but not perfect, weak. This one is close to negative 1. Compared to this one, this is more close. So there's a strong negative correlation. And here r equal to positive 1, perfectly 1. So it's a perfect positive correlation because all points, they lie perfectly on that straight line. Next example, let's see, calculate the correlation coefficient for the number of years students are out of school and annual contribution for the school using formula. So we want to calculate the correlation coefficient. We are asked to calculate, so we are going to use the formula and calculate. Also they have mentioned here using formula. So we are going to use the formula and calculate the correlation coefficient. If you remember the formula from the previous slide, it was r equal to n times sum of x times y minus sum of x multiplied to sum of y, all divided by, in the denominator there are two square roots. In the first square root you have n times sum of x squared minus sum of x quantity squared in the first square root times in the second square root sum of n times sum of y squared minus sum of y quantity squared. So we are going to find these values. So what we are going to do is, first we are going to enter this data in TI-84 calculator. So here is my TI-84 calculator. we go to stat and then hit number 1, edit, and then in list 1 we enter the x value, and in list 2 we enter the y value. After we enter the values in list 1 and list 2, we go to stat and then we go to calculate. Because we have two variables, now we are going to select two variable stat, which is number 2, and then make sure you have x list. In x you have the x values in list 1 and y values in list 2. We don't have any frequency, so we calculate that. And from this screen you are going to copy all the sum. Like here you can see the sum of x is 88. This one, sum of x is 88. Then sum of x squared is 1836. Then down here, sum of y is 56.7. Scroll down, you'll see sum of y squared 587.05. And then if you scroll down a little bit, you'll see sum of xy. So there are 5 sums with this sigma sign. There are 5 of them, and you are going to copy all of them. After we copy all these values, we are going to plug into this formula. Let's plug in one by one. So let's find the value of r. Now r is equal to, here you have n means how many pairs are there? There are 7 pairs. So 7 times sum of x times y, which is 435.6. 435.6, then minus sum of x is 88. Sum of x is 88 times sum of y. We have sum of y here, which is 56.7. 56.7. That's what we have in the denominator. Divided by, in the denominator we have 2 square root. In the first square root we have n times sum of x squared, n is 7, times sum of x squared. Sum of x squared is 1836. 1836 minus sum of x quantity squared. Sum of x is 88, so we have to square that. So 88 is squared. That's what we have in first square root. Now in the second square root we have n times, n is 7, times sum of y squared, which is 587.05. 587.05 minus sum of y quantity squared. Sum of y is 56.7. 56.7. We have to square that. Now, using calculator or by typing this in calculator, we have to find the value of r. So if we type that in calculator, okay, if we type that in calculator, we'll get negative 0.9078. Negative 0.9078. So that is the value of the correlation coefficient using formula. Also, we are asked to verify our result using calculator. So we have to check whether r is negative 0.7078 using calculator. So go back to the calculator. We already have the data entered here. So we have to go to stat, and then we have to go to calculate, and then select number 8, which says linear regression. Number 8, linear regression. So the x values must be in list 1, y value must be in list 2. There is no frequency. We don't want that equation right now. We go to calculate and hit enter. Okay, I can see that my calculator is not giving me the value of r. So in this case, maybe we need to go to mode and then check here. My stat diagnostic is off. So we need to turn that on. So if I come down here and turn this on, okay, it's on. Now again, let's go to stat, calculate, and number 8 this time. Okay, everything is same. Now we calculate and see what we get. We get the value of r. R equal to negative 0.9078. If your calculator does not give you the value of r, you have to go to mode and then make sure this stat diagnostic is turned on. Then you can find the value of r. Number 8 there. Okay, so check here. R is negative 0.9078, which was the calculated value, negative 0.9078. We verify that using calculator. Now we are asked to interpret the result in context of the data. So here R is negative 0.9078. Meaning of that is there is a strong negative correlation between the number of students out of school and their annual contribution. There is a strong negative correlation between number of years the student is out of school and their annual contribution. That means as the number of year increases that they are out of school, the amount of money they contribute in their alumni fund or in the fund to the school or to support the school will decrease over time. So that is the end of this video. This is the first part of the video where we learn about some basic terminology related to correlation. We talk about a scatter plot. Okay, we look at the way to construct this scatter plot. Then we talk about the correlation coefficient. We learn how to interpret the correlation coefficient. And then here we calculated the correlation coefficient using formula. We verified the result using calculator, and we interpret the value of r. So that is the end of this video. Thank you so much for watching.